So lately at Envision, I've been building a reporting module for our enterprise clients. And the issue that I'm running into with reporting is that depending on the size of the enterprise, some reports run in milliseconds and some reports run in minutes. Now, for reports that run quickly, ideally what I'd like to do is present the data to the user immediately. However, for reports that run longer, I can't necessarily have the user sit and wait for a variety of reasons, not least of which is that the CDN might cut off the request, or the Elastic Load Balancer might cut off the request, or the Kubernetes ingress might cut off the request, or the Nginx proxy might cut off the request. A whole bunch of things might terminate the request at any moment. So I don't want the user to sit and wait indefinitely, so I want to be able to, for longer running requests, for longer running reports, alert the user asynchronously via email. So I've been experimenting with using CFThread to implement this. So I have a demo here where I can run a report with 1,000 milliseconds, 3,000 milliseconds, and 5,000 milliseconds. And I'm going to treat the 3,000 millisecond time roughly as where I want the cutoff to be in terms of how long I want the user to wait. And here's a terminal down here and you'll see the output. So if I run the report in 1,000 milliseconds, you'll see that we immediately download the report, this JSON file, to the user's computer, and you can see in the terminal it says that the report data was consumed by the parent request. No action is taken because we've already given the data to the user. Now if I run the 5,000 one, we'll block and wait for 3 seconds, 3,000 milliseconds. At that point, you see we show the user that the report is still running in the background, but here in the terminal you can see that we've actually sent the report via email after the report was generated. Now if we go back and let's try the 3,000 millisecond simulated latency, because that's roughly the time that we're going to wait, sometimes we run into an interesting race condition. Let's see if it happens. All right, that one, so it said it's running in the background. Let's try it one more time. Sometimes what you'll see is that we download the file to the user and then we also get a sending report email, simply because there's a tiny, tiny race condition, and in that race condition we're erring on the side of alerting the user asynchronously, even though it might be unnecessary. So let's take a look at how this works. So if we jump over here into the index page that we were just seeing, here's the simulated latency that I'm passing through to my report page because I'm not actually generating any report data. And in the report, that's where the magic happens. So I'm going to skip over this run report for a moment. And what you'll see is that the parent request is going to call that run report user-defined function and tell it to wait for up to 3,000 milliseconds or 3 seconds. At that point, it's going to return a value. That value will either be null if the report continues to run in the background, or it will be the report data. So if that data is not null, if it's the result of the report, then we're going to set the content disposition to be an attachment. That's what downloads the file through the user's browser. And we're going to stream the content of that report data to the user. Now the CF content tag will implicitly abort the request. However, I'm including abort here just to underscore the fact that nothing else is going to happen. Now that only happens if the data is returned from the run report method. If no data has been returned, this is null. And if it's null, this whole if block gets skipped, which means that the rest of the parent request can continue to execute, which is where you see we alert the user that the report is going to continue to run in the background. So how do we get this conditional block and wait to return data sometimes and return nothing sometimes else? So now let's go ahead and take a look at this run report. So the run report is going to inside use a CFThread tag to execute the report generation asynchronously. But we're going to use a closure to have the thread, the CFThread, communicate with the parent level request. And it's going to change the outcome of the report generation based on this onResults action. By default, it's going to be a no-op or noop, which just means that the report generation isn't going to do anything after the data has been generated. However, what you'll see if we look in the onResults closure here, at some point we can change that onResults action to be an email, which is when we get that asynchronous notification for the user. So now let's take a look at the thread. So we're going to run this async report thread. We're going to pass in the simulated latency, which is just how we're going to simulate the fact that the report generation runs for some period of time. And we're going to pass in that onResults closure, right? This closure here. Now, inside of the CF thread, after we simulate the report generation latency, we're going to take the results of the report and we're going to insert them into the thread scope. The thread scope is essentially the public set of attributes that we can access on the CF thread outside of the CF thread execution context. After we do that, we're then going to invoke the onResults closure and pass in the results. Now there's a small race condition here, which we'll talk about in a second, in which we publicly set the results and then call the onResults handler. Now after we spawn that CF thread, which is going to generate the report asynchronously, we now tell ColdFusion to sit and block for that async report thread to join, but we're only going to tell it to sit and block for up to the given wait timeout, which is the value we passed into the run report, which is 3,000 milliseconds or 3 seconds. So at this point, right after the CF thread call here, we know that the async report tag, the CF thread tag, has either finished processing, in which case the results attribute, right, the thing that we're setting right here, has been set, or it's continuing to process in the background. If it's continuing to process in the background, what we want to do is switch that onResults action to be an email so that when this onResults call gets invoked, the user is notified asynchronously. Now here's where the slight race condition happens. But first let's just say, and then we return the results if they're available. Otherwise we just return the null value. So imagine here, we get to this point in the code and the report has not even completed execution. We set the onResults action to email, which is fine because nothing's happened yet. This is going to be called eventually, and at this point the results are still null. Now imagine that we get to this point in the code where we've blocked and waited, and we're right here. So the thread.results have been published, but the onResults method maybe hasn't been called yet. In that case, we're switching over to the email outcome, which means the user will be notified asynchronously, but the results have also been published, which means we're about to show the results to the user. So there's a tiny, tiny race condition there where we may end up downloading the file to the user and sending them an email asynchronously. But to me, this is totally acceptable. We're erring on the side of making sure the user gets notified, even if in the tiny edge case that notification is superfluous. So again, just to recap here, let's clear this data out. If we run the report in under 3 seconds, we download it immediately to the user's computer and no asynchronous action is taken. If we run the report in 5 seconds, which is 2 seconds past our timeout, you can see we tell the user that it's about to time out and we continue to send the report in the background. Now let's see if I can get that 3-second race condition to happen. Sometimes it happens. No, let's try one more time. Come on. Nah. Anyway, again, sometimes it would have downloaded and sent the email. But anyway, so I think this is a kind of a cool exploration here. It's a way for us to create a better user experience for when the reports are generated quickly, but also continue to notify the user if the reports run longer than we're going to allow the user to sit and wait. So anyway, just a fun exploration, something I think I might try in my reporting module. And you know, I think it's worth just calling out how awesome the CF thread tag is in ColdFusion. I know that there's always a lot of talk in the programming world about how complicated parallel processing, parallel computing is, but I feel like the CF thread tag in ColdFusion just removes so much of that complexity and makes things a lot easier, which I think is why in the ColdFusion world you don't often hear people talking about the complexities of parallel computing, because CF thread tag is just awesome.